Hi, my name is Preston Ward, and today I'm going to be talking about using unsupervised document clustering to facilitate coronavirus research. Um, my motivation for looking into this is just how widespread it is and how little we know about it, and to try to help efforts forward. So my initial plan was to go through and look for data sets and just see what I could find and just start doing some exploratory work. And that's when I came across that Kaggle had actually released this thing they're calling Cord-19, and they had 10 objectives, and all of them have to do with the spread of viruses and incubation times and vaccines. And I know nothing about these things, and so I wanted some way to help, and so I started looking into natural language processing techniques that could help here. And I came across unsupervised document clustering, which I thought could be a good way to group these documents in clusters so that you could minimize your search space if you were looking for something. And so there are two approaches that I took here. One is TF-IDF, and this is the simplest form that you can take. It's one of the oldest and very easily interpreted. And essentially, you weight words very high if they show up only in one document, but a lot, so giving them meaning. Or you weight them very low if they show up in a lot of documents across the entire document corpora. And then the second one is this proposed unified framework that basically you capture the semantic information of the words versus the documents in a bipartite graph, and then you cluster those together to form a hierarchy of topics where the words describe those topics. And so for TF-IDF, we don't have time to go over all this, but essentially what you're trying to do is project that incredibly high dimensional space to a lower dimensional one, and then using something like k-means to classify the clusters. And so the dimensionality reductions I used here were PCA and UMAP, and we end up with something that looks like this. And so we have nice clusters of documents, and we can clearly see that this red one here in the middle is the biggest, and that's because it had contained the word virus. And one of the issues with it is that you don't have any semantic information, and it really is just a raw count of the words, and that's not very satisfying. And so this other approach, at a very high level, it takes and separates document nodes and word nodes so that they are opposite of each other in a bipartite graph. And then they become clustered together, and the stronger they are clustered, the higher the weights on their edges will be. And so this gives a natural hierarchical structure where the trivial case is always the deepest, and we have that semantic relationship going out. And so here is that algorithm described in that paper run over our documents. And you can see the hierarchical structure that's forming as it goes in with that single node in the middle connecting them. And all of these branching edges that are coming out here with the different colors represent the different topics for those levels. And so the trivial levels we can kind of think of as stop words. So words that are too common across everything to get that we should just get rid of them because they provide no information. And so I thought it would be interesting to see if we took out all the stop words and then ran it, what we would come up with. And what this comes up with is actually all of the highest frequency words in TF-IDF, which makes sense and is a pretty interesting thing to see. Finally, another interesting thing is that the group membership can be represented by the conditional probability of a group given a node. And so since words and documents belong to different groups, essentially, so it's a bipartite graph, we can show separately that the probability of document D belonging to that document group is the same thing as the probability of a word belonging to a word group. And that also makes sense, but yeah. And so thank you for listening, and if you have any questions, please feel free to email me.